Today let's go over an easy question that I solved about 3 months ago. This one I didn't make a video about. It looks like I solved it by myself, so let's go over it again. So it's asking you to find the minimum positive sum subarray. So you're given two integers, first of all an integer array, a list, and then two integers, L and right. And your task is to find the minimum sum of a subarray whose size is between left and right. So essentially what this means is that the size of the subarray has to be of either length 2 or length 3, and whose sum is greater than 0. So positive results only, other than -1 if there's not a result that's bigger than 0. So here, for example, try to find subarrays of size 2 and also try to find subarrays of size 3. And if they match, then return them. Same here, subarrays of size 2, subarrays of size 4. There's only one of them because the whole array is of length 4. So then you just return, looks like the biggest sum of the subarray is, well, let's see here. We want to find the minimum sum, sorry, not the maximum sum. So if you want to find the minimum of anything, let's go ahead and declare a variable called infinity, because nothing is bigger than infinity. Anything is going to be smaller than infinity, so that when we update the result, then it's always going to be smaller. And let's say this is the first size. Let's call this L. And then let's just slide the window over nums L times. As many windows of L size as we can make through nums. So let's say for I in range length nums minus first plus 1. And let's call this subarray equals to nums I plus first, because that's the size. And then we update result if the sum of the subarray is smaller. So we're going to do 3 minus 2, and then we're going to do 2, 1, and then we're going to do 1, 4. So we're not skipping elements as like this. We're doing this, this, and this because they're size 2. And then we're doing this, this of size 3. So think of it as a fixed size sliding window from left to right. And then now we can do the same thing for the right one. So same thing, length of nums minus second plus 1. Subarray equals to nums of I plus second. So this is the one of size 3. Just to prove it to you, let's print it out. So size 3, right, from left to right. And now, same thing. If this subarray is a smaller sum than the historical result that we found so far, then update result to be that new minimum. And then at the end, if result has not changed from the beginning, after we checked all the windows of both sizes, if result is equal to float of infinity, then we can just return -1, as it says right here, if no such subarray exists. Otherwise, we just return the result because that is bigger than 0 somehow, and less than infinity. So, okay, looks like this doesn't work. Okay, so results, sum of subarray. Let's print our subarray out. Okay. So it looks like I might have misread because 2, 1 is not included. So maybe we should actually jump by 2. So doing this to here instead of what I said, just sliding the window. Let's try that. Okay, so probably the same thing here with the other one. The step size is 2, so instead of a 1 step size, we're making a 2 step size if it's possible. So let's try this. Still no. Okay. So subarrays between left and right. Okay. So I guess we also have to slide the window through everything between left and right, so size 3 as well. So now this problem just got a little more tricky. Let's do this again. So now we can't even use the sliding window technique. Let's just generate all the subarrays. Brute force, so 3, 3, 2, and 3 minus 2, 3 minus 2, 1, 3 minus 2, 1, 4, minus 2, minus 2, 1, minus 2, 4, 1, 1, 4, and then 4. All the subarrays. So subarray, and then let's just say if the length of the subarray is between left and right, inclusive, right? So if left is less than or equal to length of subarray, which is also less than or equal to right, then we can take the minimum of the sum of the subarray. And then at the end, again, if the result hasn't changed from the beginning, we haven't found any valid subarrays, so as it says, we have to return -1, else we can just return the result. Okay, this is still not working. Size is between left and right inclusive. Huh, okay. Let's see here what is going on. Yes, 1, 4. So this is not a valid subarray. Oh, whose sum is greater than 0. Okay, so if the sum of the subarray is greater than 0, then we do this. Okay, and output limit exceeded. Might get time limit exceeded too. Okay, we didn't. There we go. So not very efficient. We can make this a little better by doing this, so we don't have to recompute the length, which is O of n every time. And also, let's call this the sum of the subarray. Let's say SS. Let's call this original. Okay. I guess not. Okay. Anyways, this is my own brute force solution. I have not really solved this in a while, so this is just on the spot as usual. So thank you for watching. I hope this video was helpful, at least to give you an intuitive, basic understanding of how to solve this. And please stay tuned for more.